notes would be trinomial. I totally forgot. I already started it here. So I think you just got recorded doing that.
It's okay.
What I will do on the camera, the videos, I'll trim it so you're off.
Okay.
Because I forgot like getting students on me. Sorry. All right, so trinomials. Okay, so trinomial is what?
3 terms.
3 terms. Outstanding. So 3 terms. Now there are 2 parts to this one. We're gonna do one of them today. We'll save the other one for our special guest speaker coming on Monday. Teaching a lesson that I abhor. I just hate the second one of these. So because I hate the method, but it always works, kids love it, I have a special guest speaker coming in to teach that on Monday. So part A is going to be trinomials. So what we're looking at is when A equals 1. That's the first type of trinomial. So example, something like, let's say x squared plus 6x plus 5. I have a factor, a trinomial like that, and we say to factor that. So if you remember, it's going to come down to 2 binomials. 2 binomials equals a trinomial generally. Okay? And do you remember how we factor the trinomial?
It multiplies to the last one and adds to the middle one.
Okay, so we look for something that multiplies to equal 5, but adds to equal 6. Multiplies to C, adds to equal B. Okay, so we know the x squared, we split it up, x and x. Okay? So what multiplies to equal 5 but adds to equal 6? 5 and 1. In fact, it's nice when this is a prime number because you only have one option. It's got to be 1 and 5. And there's your answer. Now these do get a little more difficult because as this becomes bigger, you have more options. It becomes more composite, has several options. You have to kind of look and see. Also with signs. So let's look at a couple examples of this. I have some of my notes. Let's look at another kind of basic one. X squared plus 4x minus 5. So once again, kind of easy because negative 5 only has 2 possibilities, right? What things multiply to equal negative 5? Negative 1 and 5, or? Say it again. 1 and negative 5, back and forth. So I guess we're looking, if you're looking for like shortcuts or little cheats, if this sign right here is negative, what does that tell you? If that sign is negative, what does that tell you about your 2 factors? Yep, you'll have 1 positive and you'll have 1 negative. Okay. If this sign is positive, say it again. Both the same. And this term will tell you what they are. Okay? Because if this was, just hypothetically speaking, if this had been x squared minus 6x plus 5, it's still the same answer. These are just both negative. Okay? This tells you that they're both the same. This tells you what they are. Okay? So in this case, since we have a negative here, I know I'm going to have 1 positive, 1 negative. So I'm going to have x and x. I know I'm going to have 5 and 1. Which one is positive? Which one is negative? Say it again. How do you know that? Yeah, so it has to be a positive 4. So what that tells us then is the bigger number has to be positive. Okay? So positive 5, negative 1. So x plus 5, x plus 2. So there are some little cheat things as you're kind of thinking through about the signs. If you don't remember those shortcuts, then you're just looking at all the factors that equal. All right, how many of you remember this? Yes, a couple of you. All right, very good. This is probably one of the most important concepts of math that we have to be able to do over and over and over. Okay, let's try another one. Let me put 2 on the board and you try these. X squared minus 2x minus 15. And let's go with x squared plus 13x minus plus 42. Try this two.
Is it plus 42 or minus 42?
It's supposed to be plus 42.
I didn't know if you changed it.
I did change it because minus 42 wouldn't work. Not that I know of anyway. Okay, let's look at the first one. So if we're looking for negative 15, what multiplies to equal negative 15? You simply can start by writing all the factors. So negative 1 times 15, 1 and negative 15, negative 3, 5, 3 and negative 5. Okay. So then which one gives us a sum of negative 2?
The last one.
Yep, we know x and x. We have 5 and 3. And since 5 is larger, that's going to be the negative and 5. So x minus 5 and x plus 5. You got a question?
No, I didn't know. I was trying to see, it doesn't matter which one, like, you put x plus 3 or x minus 5 first.
Doesn't matter. Yeah, remember these are commutative, so. And I can't say I ever do it one way or the other, I just whatever feels right. All right, what about the bottom one? What multiplies to equal 42 but adds to equal 13?
6 and 7.
6 and 7. So if you can just start listing all the things that multiply to equal a positive 42. So 142, 221, 314, 6 and 7. So then which ones add? So you get x plus 6 and x plus 7. Questions on those two? Kind of makes sense? Kind of remember it? Okay. 2 challenge ones. There you go. 2 more. I better do the first one with you, then I'll give you the second one to try on your own. So what if I give you x to the 4th minus 4x squared? And it would help if I could read my own handwriting. Plus 60. And I ask you to factor this one. First of all, it's different with the x to the 4th, right? I have x to the 4th, I have x to the squared. There's still a relationship, it's exactly half. And then there's a constant. So what does that mean with my first 2 terms?
They're going to be x.
They're going to be what?
They're gonna have the exponent.
They're going to have an exponent squared. So they're both going to be x squared. So we call this a quadratic form. It's kind of like a quadratic, although it's a quartic function. Okay. So everything else is the same. This one tells you they're both the same. This one tells you they're both negative. Oh my goodness, do I have an answer here? I think I screwed up. I did this off the top of my head. I think I screwed up.
6 and 10.
Is it plus 4x? It would minus
No, I
6.
think what I wanted was I wanted this to be negative.
Yeah.
I think I want that to be negative because now it could be.
Could 6 and 10 work?
It will
Not
now.
positive.
Which one has to be negative then?
That's negative. No, 6. You minus 6.
Yeah, 6 because the 10, the large number is going to be the negative. Now, I have a binomial, right? I have two binomials. I have a perfect square. I have a difference. Is 10 a perfect square? So I can't factor that one. So then I won't be done. All right, you try this one. Let's see what time is it. Maybe the last one for the day. We'll see. Oh, good. Let me make sure this one works. Hang on. Give me a second. Plus means they're both negative. Okay, this one works. Here we go. X to the 4th minus 13x squared plus 36. Factor completely. Yes.
So anytime it's x to the 4th, it's going to be x squared.
So yes, so anytime it's in a quadratic form where we have like this is exactly twice of that number. So I could honestly I could put x to the 6th and x to the 3rd.
Okay.
Or I could put x to the 10th and x to the 5th.
So it's going to be whatever is happening.
And then we'll always be in the middle. Correct. Did you factor completely? Completely. Yes, Jordan.
What do you do with this square here? What do you use of squares?
Is it the difference of two squares?
Yeah.
So then you have to do,
Bottoms up.
no. Bottoms up I hate. That's what our guest speaker is going to be talking to me, bottoms up. And that's on Monday. That's where you go back to Roman numeral 2 with two terms and the difference of two squares. That's one of your special cases.
Oh.
Oh.
You did it right. How many factors do you have at the end? You have what?
I don't know. I mean, I think I did it right.
Okay.
But I feel like I did it. Cause I had yeah.
I think
Okay, don't give up way too much.
Oh, yeah.
like 4 like different terms? Oh. Oh, I know.
All right. What are my factors of 36? What multiplies to equal 36?
218.
6 and 6. And which one does this have to be?
4 and
4
9.
and 9.
4 and 9, because that adds up to equal negative 13. So I have to go negative 4 and negative 9. But I'm not done, Sydney. Tell us why. I have the difference on both of them, and they're all perfect squares. So x squared minus 4 becomes what?
X minus what?
X minus 2.
Oh yeah.
And it doesn't matter which is plus, which is minus. So the x squared minus 9 becomes
X minus.
x minus 3 and x plus 3. Now, don't ever ask me the question, do we need to factor down? The answer is always yes. It's kind of like since 5th grade when I gave you something like 10 over 30. Do I need to reduce that fraction? Of course you do. Of course you have to give me 1/3. The same thing here, we have to go down to prime factors every single time. Okay, so you have to examine this, and you should just recognize the difference. 2 perfect squares is the only way to do it. You have to recognize it. Factor into it. So you should end up with 4 factors there. All right. Yes, ma'am.
What if it was just like x minus 40? You still have to go into it first, or do you have to be x squared to do?
Has to be a perfect square. Now,
Is it one?
I can take a little step further to show you.
That's still x and 4 have to be squared, or can you do like x minus 4 and then go down? Or something?
So technically you can. Do you want to see it?
No, okay.
It's a little bit more at the next step, but
Will we have to redo it this year?
probably not.
Okay, no.
But I can still show it to you. You don't want to see it because I really want to show it. So did you ask the question?
Let's see it.
Thank you. You can just close your eyes, okay? If you have x minus 4, you can factor it. What's the square root of x?
-1.
No.
Okay.
Isn't it just like the weird box thing with X in it?
Square root of
Yeah,
x,
that's-
square root of x.
Oh.
Square root of 4 is
2.
2 and 2, one's plus, one's minus.
Oh.
So you can actually do it to any function.
not that hard.
You could actually factor x minus 2, because you have the square root of x
Square root.
minus the square root of 2, and you have the square root of x plus the square root of 2. It really works.
But why would you do that?
I'm sorry?
Or like, why would you do that? You just do that.
There are some applications where you might want to do that, but it's going to be the next level.
So you can really do it even if it's a prime.
You can do it even if it's a non-perfect square. But for our class, the key is, and that's not really factoring it, factoring over the integers. We want to factor over integers. All right, very good. All right, some people are packing up, even though it's still 5 minutes to the class, but that's okay. We are done. We are ahead of the other class. The other class hasn't done sum difference of cubes yet, so they have to do sum difference of cubes in this today. I trust you have a fantastic weekend. I'll see you Monday.